In lesson 4.2, we want to take a look at what happens in a different type of rational function. So we're going to start by looking at this one I have graphed here. It is x squared minus x over x plus 1. So we've got it here on Desmos, and it looks like we have a vertical asymptote at -1, which we would know from what we did previously. If we set the denominator equal to 0, we do have a vertical asymptote at x equals -1. So there it is. Now, if I zoom out on this, it appears that there may also be an asymptote that's kind of at a slant through this. So we call that a slant asymptote or an oblique asymptote. And the way we find those is a little bit different because what we talked about previously was only vertical and horizontal. And clearly this is not vertical or horizontal. So going over to the notes, if we have a rational function, if the degree of the numerator is exactly 1 more than the degree of the denominator, then the graph has a slant or oblique asymptote. So the one that I was just showing you is right here. So to find the slant asymptote, we use long division. So let's take a look at this. We want to take this numerator, x squared minus x plus 0, and we want to divide it by the denominator, x plus 1. So we're just going to use our long division. So we need an x on top, which will give us x squared plus 1. I'm sorry, plus x. Draw the line and change the signs. That's a negative. So negative 2x plus 0. So we'll need a minus 2. And then we get negative 2x minus 2. Draw the line and change the signs. I apologize if that's sloppy. We get to ignore the remainder on this, okay? So who cares about the remainder? This is the slant asymptote. The slant asymptote is y equals x minus 2. So going back to Desmos, if we put that in here, let's see. We actually need to get the menu. Y equals x minus 2. You can see, let's change the color on that. There, that'll work. Get all these out of the way so you can actually see it. There is our slant asymptote. And as you zoom out, you can see it a little better. And zooming in, you can see it a little bit better. So we're going to use that along with all the steps that we were doing in 4.2a to find out how to graph these things. Okay, so we want to sketch a graph of this thing. I'm just going to erase this so we can see what's going on. We want to sketch the graph of 3x squared plus 1 and state the domain. And we're going to use the same steps as we did before, just including slant asymptotes when we need it. So again, the first step is always going to be to factor and simplify if you can. This one, there's nothing to factor, so we're just stuck with it. So let's go ahead and find the x-intercepts. Plug in 0 for y. I'm going to multiply both sides by x. And I'm going to subtract 1 and divide by 3. I'm going to do that all in one step. And notice if I take the square root of that, we're in imaginary numbers. So there are no x-intercepts. All right, to find y-intercepts, we're going to plug in 0 for x. So 3 times 0 squared plus 1 divided by 0. Can't divide by 0. So there are no y-intercepts either. Okay, vertical asymptote. Those are when we take the denominator and set it equal to 0. So we do have a vertical asymptote. There it is. Horizontal asymptote. The degree of the numerator is 2 and the degree of the denominator is 1. So if the degree of the numerator is greater than the degree of the denominator, that means there's no horizontal asymptote, so none. But the degree of the numerator is 1 more than the degree of the denominator, so that means there is a slant asymptote. And we are going to find that slant asymptote by using long division. So 3x squared plus 0x plus 1 divided by x plus 0. So it looks like we'll need a 3x on top, which gives us 3x squared plus 0x. Those cancel. It looks like our remainder is just 1, which we get to ignore. So this right here is our slight asymptote, y equals 3x. So we're going to graph that line. Goes through 0, 0, and a slope of 3. So there is this asymptote. That's not the straightest line you've ever seen. Okay. Now, when we draw this, we're going to have to plot some points, but our graph is either going to be here and here, or, let's see if we can get rid of that. There we go. It's going to be here and here. Okay, so it's always going to be in like kind of opposite quadrants of each other. We just have to figure out which one it is. So let's get rid of that because we don't know which one it is until we plot some points. So I'm just going to set up a little table of values. We don't have to plug in a lot. We can't plug in 0. So -2 and -1 is a good choice. And then maybe 1 and 2. And we'll plug them in. Don't forget to put your numerator in parentheses. So when we plug in -2, we get -6.5, -1, -4. If I plug in 1, I get 4. And if I plug in 2, I get 6.5. Okay, so -2, -6.5, that's barely on the graph. And -1, -4. So it looks like it's the skinny thing like that. And then 1, 4, and 2, 6.5. So it looks like we're going to squeeze in there. All right, in the last video, we'll tackle that last graph.